Welcome back to the Best Writing on Mathematics channel. In this video, I will present an overview of the fourth volume in the printed series on the Best Writing on Mathematics, the 2013 edition. As with any other volume in the series, I put together a book I would like to read. A book I did not find in the bookstore many years ago when I looked for it. If I include a contribution, it does not mean that I necessarily concur in the opinions expressed in it. Whether we agree or disagree with other people's views, our polemics gain in substance if we aim to comprehend and address the highest quality of the opposing arguments. In a sweeping panoramic view of the likely future trajectory of mathematics, Philip Davis asks pertinent questions that illuminate some of the myriad links connecting mathematics to its applications and to other practical domains, and offer us informed speculations on the multifaceted mathematical imprint on our ever more digitized world. Jan Stewart explains recent attempts made by mathematicians to refine and reaffirm a theory first formulated by Alan Turing, stating in its most general formulation that pattern formation is a consequence of symmetry breaking. Terence Tao observes that many complex systems seem to be governed by universal principles independent of the laws that govern the interaction between their components. He then surveys various aspects of several well-studied mathematical laws that characterize phenomena as diverse as spectral lines of chemical elements, political elections, celestial mechanics, economic changes, phase transitions of physical materials, the distribution of prime numbers, and others. A diversity of context with primary focus on social networking is also Gregory Gost's object of attention. In his article, he examines the small world problem, the quest to determine the likelihood that two individuals randomly chosen from a large group know each other. Charles Seefe argues that humans' evolutionary heritage, cultural mores, and acquired preconceptions equip us poorly for expecting and experiencing randomness. Yet, in an echo to Tao's contribution, Seefe observes that in aggregate, randomness of many independent events does obey immutable mathematical rules. Writing from experience, Donald Knuth shows that the deliberate and methodical co-opting of randomness into creative acts enhances the beauty and the originality of the result. Soren Johnson discusses the advantages and the pitfalls of using chance in designating games and gives examples illustrative of this perspective. John Pavlus details the history, the meaning, and the implications of the P versus NP problem that underpins the foundations of computational complexity theory and mentions the many interdisciplinary areas that are connected through it. Renan Gross analyzes the geometry of the Jerusalem Quartz Bridge and relates it to the mathematics used half a century ago by the French mathematical engineer Pierre Bézier in car designs, an elegantly simple subject that has many other applications. Daniel Silver presents Albrecht Dürer's Painter's Manual as a precursor work to projective geometry and astronomy. He details some of the mathematics in the treatise and in Dürer's artworks, as well as the biographical elements that contributed to Dürer's interaction with mathematics. Kelly Delp writes about the late William Thurston's little-known but intensely absorbing collaboration with the fashion designer Dai Fujiwara and his Issei Miyake team. She describes the topological notions that surprisingly turned out to be at the confluence of intellectual passions harbored by two people so different in background and living on opposite sides of the world. Fiona and William Ross tell the brief history of Jordan's curve theorem, hint at some tricky cases that defy the simplistic intuition behind it, and, most remarkably, illustrate the non-obvious character of the theorem with arresting drawings penned by Fiona Ross. To answer pressing questions about the need for widespread mathematics education, Anna Svard sees mathematics as a narrative means to comprehend the world, which we humans developed for our convenience. She follows up on this perspective by arguing that the story we tell and teach with mathematics needs to change in sync with the unprecedented changes of our world. Erin Maloney and Sian Beilock examine the practical and psychological consequences of states of anxiety to our mathematical activities. They contend that such feelings appear early in schooling and tend to recur in subsequent years, have a dual cognitive and social basis, and negatively affect cognitive performance. The authors affirm that the negative effect of mathematical anxiety can be alleviated by certain deliberate practices, for instance by writing about the emotions that cause anxiety. David Lloyd reviews arguments put forward by proponents of the idea that the 5 regular polyhedral shapes were well known as mathematical objects perhaps 1 millennium before Plato in Scotland, where objects of similar configurations and markings have been discovered. He concludes that the objects, genuine and valuable aesthetically and anthropologically, do not substantiate the revisionist claims, at least as far as in the mathematical knowledge they reveal. In the interaction between the material culture of mathematical instruments and the mathematics that underline it from 16th to the 18th centuries in Western Europe, Jim Bennett decodes subtle reciprocal influences that put mathematics in a nodal position of a network of applied sciences, scientific practices, institutional academics, entrepreneurship, and commerce. Frank Quinn contrasts the main features of mathematics before and after the profound transformations that took place at the core of the discipline roughly around the turn of the 19th century. He contends that the unrecognized magnitude of those changes led to some current fault lines, for instance, between teaching and research needs in universities, between school mathematics and higher mathematics and others, and in the future might even marginalize mathematics. Prakash Gorroochurn surveys a collection of chance and statistics problems that confused some of the brilliant mathematical minds of the past few centuries, and initially were given erroneous solutions, but had an important historical role in clarifying fine distinctions between the theoretical notions involved. Elie Ayache makes the logical philosophical case that the prices reached by traders in the marketplace take precedence over the intellectual speculations intended to justify and to predict them. Therefore, the contingency of number prices supersedes the calculus of probabilities meant to model it, not the other way around. Finally, Kevin Hartnett reports on recent developments related to the ABC conjecture, a number theory result that, if indeed proven, will have widespread implications for several branches of mathematics. Besides these contributions reproduced in this volume, I included at the end a list of Osoran, of notable texts that were published in the year previous to 2013, but I did not include in this volume. With this, I thank you again for listening to our videos and watching them.